Okay, let's go to the second one. Okay, second question. Actually, this is the second question. Okay, so here, what is linear time invariant system? Okay, so you know that linear time invariant system means the system is linear. The system should be linear. Okay, the system should be linear, and system should be time invariant. Time invariant. Okay, we have discussed these things. Okay, actually, in modern control theory also we have discussed. Okay, linear means so if you are given input, you will have the output, and there is a process in this signal. Okay, so linear means, okay, linear means if you have another signal, if you, let's say that you are given x1t, your output will be y1t, and if you are given x2t, your output, let's say that it is y2t, and if you are given x1t plus x2t, your output will be y1t plus y2t. And if you are given this weighted signal AB, okay, the resultant also will be have the same weightage AB. Okay, so this is the condition for linear. This is the condition for linear. Okay, try to remember this one. Hari, make a remember කරගන්න. මේ වගේ equation එකක් දෙන්නේ නැහැ. හරි? Exam එක. So you are not given this kind of equation. So this is simple things, no? So you have to keep remember this one. Okay, so you can write something. Okay, if you are asked to write linear, so anyway you can write. Okay, it's not should it may be not perfect, but you will get the marks. Okay, හරි මේක හරියටම ලියා ගන්න බැරි වුණත් සාමාන්‍ය මට්ටමකට ලියුවොත් මේකට ලකුණු හම්බ වෙනවා කට්ටියට. හරි. එතකොට linear කියන එකේ මේක තමයි A1 bx2t දුන්නොත් input එක විදිහට ඔය කට්ටියට හම්බ වෙනවා ay1t plus by2t. then මේක තමයි linear. Okay, time invariant means, okay, if you are shifting this signal, input signal, some value, okay, the output also will be shifted this in the same value. Okay, so the time invariant means if you shifted the input value any direction plus or minus t, your output also will be plus or minus t. Your output also will have the same shift. Okay, same shift you will have. So I think I have explained this with some example. Okay, maybe you can remember that. Okay, we take rectifier as an example. Okay, if the so I asked the rectifier system is linear or not from you. Okay, so actually rectifier system also will be linear. Maybe you can remember. Okay, if you consider the amplifier, amplifier also will be linear system. Okay, so there are many systems. There are many linear systems. Linear and time invariant. Okay, so these are rectifier also LTI system, and the amplifier also LTI system. Okay, if you can remember capacitor, if you consider capacitor, that is also LTI system. Okay, so I think we have discussed this example in our tutorial lessons. Okay, okay, so that is it. That is the linear time invariant condition. Okay, so next one. What is meant by impulse response, HN? Okay, so what is impulse response? Okay, impulse response means so these are actually discrete system. No? Okay, so instead of this t, you can put n. Okay, you can put n. Okay, so that means linear. In linear, you can write like this. n v x to n, you will get the output a y1n plus b y2n. Okay, this is the linear. Time invariant means if you are shifting your input signal plus or minus some sample value, let's say that capital N, so your output also will be shifting, capital N. Okay, so this is time invariant. Okay, time invariant. Okay, so what is HN actually? HN is the process. HN කියන්නේ process එක. මොකද්ද HN කියලා කියන්නේ? System එක HN. Okay, if you are given XN, you have the output YN. This is the input, this is the process, and this is the output. මේක තමයි process එක. වෙන process එක තමයි මේකෙන් කියලා තියෙන්නේ HN එක. මේ signal එකට වෙන්නේ මොකක්ද? input signal එකක් දුන්නා මේ signal එකට මොකක් හරි වෙලා output එකක් දෙනවා. වෙන process එක තමයි මේ HN වලින් කියන්නේ. මේ HN කියන්නේ මොකක්ද ඇත්තට? මෙයාට අපි කියනවා impulse response එක කියලා. This is called as a impulse response. Impulse response means if you are given an impulse as a input එක විදිහට impulse එකක් දුන්නොත් එහෙම the output you get, so that is the impulse response. හරි, impulse response එක කියන්නේ input එක වෙනකොට impulse එකක් දෙන්නේ delta n දෙනවා input එකක් විදිහට. ඒතර output එක yn, output එක ඔය කට්ටියට එන්නේ hn වලින්. ඒ කියන්නේ මේක තමයි impulse response එක. ඒක තමයි process එක කියලා ගන්න. හරි. ඒතර ඒක තමයි hn. What is hn? When you are given an impulse as an input, the output is hn. Output is the impulse response. Okay, so we know this relation. Okay, the yn is equal to hn convol xn. හරි, මේක තමයි අපේ රිලේෂන් එක. මාක් හරි සිග්නල් එකක් දුන්නොත් yn කියලා අපේ සිග්නල් එකේ එනවා hn convol xn. හරි, hn කියන එක convol කරලා xn. හරි, මේක තමයි එතකොට අපේ රිලේෂන් එක. හරි. හරි, මේකත් අපි කතා කරමු. Briefly explain the benefit of transforming a signal from time domain to alternative domains. Alternative domains means SOF. Right? S domain, complex domain එකට හරි frequency domain එකට හරි. ඒ කියන්නේ එක්ක Laplace transform දාන එක, එහෙම නැත්නම් Fourier transform දාන එක. Laplace analysis or Fourier analysis. Right? By Laplace analysis or Laplace transform or Fourier transform, you can transform time domain signal into complex domain or Fourier domain. හරි. ඔකට මොකක් හරි සිග්නල් එකක් දුන්නාම time domain එකේ තියෙන සිග්නල් එක Fourier analysis හරි Laplace analysis හරි දාලා එයාව Fourier transform දැම්මොත් එයාව frequency domain එකට convert වෙනවා. Laplace transform දැම්මොත් එයාව complex domain එකට මෙයනවා. හරි. එතකොට ඒකේ වාසිය මොකක්ද අපිට තියෙන්නේ? What is the benefit? The benefit is once you have put the convolution, okay, the transform to another domain, this convolution will be vanish. මේ convolution එක නැති වෙනවා. නැති වෙලා එයාව සාමාන්‍ය multiplication එකක් විදිහට එනවා. හරි. ඒක තමයි analysis. ඒක තමයි අපේ benefit එක. Then the analysis will be very easy. Not very easy, will be easy and possible. Right? So if you have hn and if you have xn and if you have the output as yn, okay, your relationship will be yn is equal to hn impulse response convert the input. This is output and this is input. This is impulse response. Okay, impulse response. Okay, so this is your relationship, input-output relationship for the LTI system. Okay, so if you transform this to, let's say that S domain, so this will be ys, hn, let's say it is hs, and this convolution will be a multiplication and xs. Okay, so this is using Laplace transform. So you convert yn into S domain, Hn into S domain, Xn into H domain. Okay. So this is we call transfer function. This is we call transfer function. Actually, this is complex transfer function. Okay. So if you convert using the Fourier transform, if you convert this to Fourier domain, the frequency domain, Y omega, H omega, and also this convolution will be vanished. This convolution will be vanished and you will get multiplication, that is X omega into X omega. Okay. So this is using Fourier transform. This is called frequency response, frequency transfer function, frequency transfer function. Okay. So that is the benefit, okay? So if you convert this time domain into S domain or omega domain, alternative domains, this convolution will be vanish and it will be a multiplication, simple multiplication. So that is the benefit. එතකොට මෙයා මේ convol එක multiplication එකක් වෙනවා මේ time domain අනිත් domain වලට transfer කරලා. හරි ඒක තමයි වාසිය. Right? Okay. So actually you no need to remember this too, okay? This will be given, okay? And what you have to do is you have to find the Fourier representation and you have to draw the magnitude spectrum, okay? Magnitude and phase spectrum. So that is what you have to do, okay? So this is DTFS, discrete time Fourier representation, okay? Discrete time Fourier series representation. So we use the exponential form, okay? For that one, we use the exponential form, okay? And if in your reference book, these are given actually, okay?